Welcome guys. So today be sure to subscribe to my video. So today I want to use the inverse Fourier transformation method to show why the constant function, right, if you do the Fourier transform for f of t to be 1, then it will become this. It will become 2 pi delta omega. So this means that we have this strange formula. Okay, so this formula looks very, this is minus j omega t. So j is an imaginary unit, so j squared minus 1 will become 2 pi delta omega. Okay, so the common way is like you just take the g alpha, you just take some, somehow like you need to use the general function theory, right? But in this video, we are trying to using other different ways, somehow like make sense of this strange formula. Okay, so now in this video, I'm trying to just using the inverse Fourier transform, right? So, okay, so if you believe that suppose you take f of t, right, you do a Fourier transform, then you get this. Okay, and you do the inverse Fourier transform, right? Then the definition. Okay, so maybe I already suppose somebody give you a function of g omega. And of inverse Fourier transform f inverse is basically defined to be 1 over 2 pi. So you see this 2 pi is some mysterious results. Okay, so it becomes g omega exponential j omega t. So one is negative, one is positive, right? The omega. Okay. Okay, so you need to believe that if you believe that f inverse f is identity, and f inverse is identity. So basically, if you take a function of t and then you do the inverse Fourier transformation, and then you do the inverse Fourier transformation, then you will become f of t. Okay, so if you believe this, then somehow like we can come up with another ways that basically we ask, what is the inverse Fourier transform? What is the inverse Fourier transform of this, right? So obvious way is that the inverse Fourier transformation of this, right, is indeed if you put t equals to 1, right? And this is also this d omega, right? So this is the same as you put omega to be 0, right? So this is 2 pi will cancel, you get 1, right? You get 1. So this is constant for every t, right? So what we have shown is that the inverse Fourier transform of this 2 pi delta omega is indeed the constant function f of t to be 1, right? So and then take f both sides, take Fourier transform, so we get 2 pi delta omega. Remember that the f inverse is identity, okay? Will become f of t. Okay, so somehow like if you believe that the inverse and the Fourier transform and the inverse Fourier transform are indeed identical, indeed inverse, then you can prove this. Yeah, but basically usually what textbook show that is that if you should use this identity to prove the inverse is indeed inverse. Yeah, but I also show this in my video list. So if you are interested, yeah, you can go there to see. Okay, I will see you guys in another interesting Fourier transformation video. Be sure to subscribe to my channel. Thanks.